2. Sorry, 3 and 1 is what? 3, 1, sorry. Yeah. So yeah, is it equals to minimum of AI comma AJ? Yeah, these two. So all these three bits will be 0 and this bit remains turned on. So basically 3 and 1 will be what? 1, right? So this condition is satisfied. So can I insert 3 here? I can. But is it compulsory for me to insert 3 here? That is not compulsory, because by inserting 3 here, now I impose another condition on this array, that now uh, you will have to be done with AI, and so basically this will become my next J, right? So the thing is that for you to understand this DP solution, you will have to make one more observation, that whenever I say that AI and AJ is equals to minimum of AI AJ, as you can see, uh, so basically, yeah, this one, it has the set bits at same positions as 3, and 3 has some extra set bits, right? But the thing is that the lesser number will always have the set bits at positions that are already set in the larger number. Like in this, 1 has set bits at position 1, which is already set in all the larger numbers, right? All the larger numbers. Because otherwise what will happen if let us say if a number right here was, I would say 16. Okay, if I had 16 in my this, okay, and I did 1 and 16. So what will happen when I do the AND of these two? AND of 1 comma 16. What will be it? It will be 0 0 0 0. Now what happened? This bit just turned off. So do I want to turn it off? No, I do not want to turn it off. Otherwise, I will not be able to obtain the minimum of AI comma AJ, right? AI and AJ has to be minimum of AI comma AJ. And in this case, if I turn off a bit from AI, is it possible? No, it is not possible. So the bits that are already turned on here should be turned on here, and the bits that are turned on here should be turned on here. Are they? Yes, they are. So these two bits are turned on here. Right. So this is the main observation here. The, now these three bits are turned on here, right? Now these three bits are turned on here as well, right? So the bits should be turned on, right? What do you mean by turn on? It is just that the bit should be 1. So this is the main observation. And why it can't be turned off in a greater number? Because uh, because what will happen otherwise, this bit will get unset, and if it gets unset, it will never be able to become equals to the minimum number, right? So that is the thing in this question. So uh, so basically this number will have more set bits than the previous number. So if I have already constructed this number, do I have to check for this number as well? If Okay, what? Listen me again carefully. So if I check that this number has all the bits of this number also set, which is the case, right? Do I have to check for this with this number as well? Like I know 1 1 is set here, and I know that 1 is set here. So obviously this will have more set bits, right? This will have more set bits, more set bits. So once I have made this number, I do not need to check the previous numbers, right? And that is the final DP approach that I will be using. So now collect all of the things I've told you. The first of the things was that AI and AJ must be equals to minimum of AI comma AJ. And the second the thing was, if I have to satisfy this condition, if I have to satisfy this condition, the set bits here must be a subset of these set bits, and the set bits here must be a subset of these set bits, and similarly for all. This case, why have I chosen this case? Because this is wholly a subsequence, which is good, and that is why I have chosen this test case for explaining. So I hope you might be understanding this. If you have any doubt right now, you can you can just okay. So yeah, now this is my DP function that I have made. Now I will be explaining how I have come up with this DP function, right? So as I told you that initially the subsequence was empty. Can I insert three? Can I insert one? Yes, because it is empty. There is no condition. Can I insert three into this? Maybe I can. Maybe I cannot. So there will be two cases right now. I can insert or I cannot insert. If I insert uh, three as well, I will get a subsequence as 1 comma 3, and now next number must have uh, AI and 3 equals to 3. Previously, here till here, sorry, basically after having 1 in the sequence, now next number must be AI and 1 is equals to 1 in order to satisfy this condition, because obviously since we are traversing in a sorted array, this condition has to be true. So AI and 1 is equals to 1, right? Um, and then we have another option that we do not insert this 3 into the subsequence, and now next number must have AI and 1. No, not AI and 1. AI and 1 equals to 1. Yes. The next number must have AI and 1 equals to 1, and we will start traversing from this index. So the DP I have is what? It should have two states, f of I comma j, f of I comma j. And now I is what? I is the current index. Like till now I have made 1 comma 3. I have visited 1 comma 3, and now I will starting with this index of 11, right? Yeah. And then next number must have AI and 1 equals to 1. So f of I comma j is equals to what? I am at index I, and last number in the subsequence was at j, was at index j. So how many more numbers can I have? This is the DP states that I am using, and I comma j are basically the indexes. So I is less than n, and thus DP is n square. And n square, as you can see in this question, is allowed. Um, in this question, n is equals to only 100, so n square is allowed in this question. So this is the state of the DP. I am at index I, and last number in the subsequence was at index j. So how many more numbers can I have? This is f of I comma j. And how will I calculate f of I comma j? I told you, if AI and aj is equals to aj, This means that this number can be inserted. Then I can uh, either take this, I can either take this, right? If I take this, then what will happen? I will go to next index. The j will become equals to I, and the size will increase by 1. If I do not take this, I will go to the next number. The previous index will be j still, and there will be no increment in the current size of the subsequence, right? So this is the approach that I will be using. Else what will happen? Return. So basically now I cannot insert this number. So for example, uh, 16 came 16 came right here, and I know that 16 will not satisfy the condition, so I cannot take it. So basically I just return, uh, go to the next index, keep the same j, and do not increment any answer. So this is more or less the DP that I have thought of. So f of I comma j is something that should be clear to you, right? Okay, so now let us see the implementation part. So I have sorted the array. I have initially assumed the answer to be 0, and then I have made a DP vector n cross n, because I and j are both in the n square, and n square is allowed in the question. So I start with the index I. I try to start from all indexes I, right? I can start from anywhere in the array. I start with the index I. I assume that my previous index, because initially we have nothing to check. So this is the bullshit condition. So previous index is at a dot size, because obviously it can't be at a dot size, right? Um, and then answer equals to max of this and this. So this is the now function that I have made for checking the DP. So this is basically just the memotization. If the answer has already been calculated, return it directly. This is the basic concept of DP. And if this is the another base case, that if I am at the end of the array, so basically I'm done with calculating all the things. So simply return 0. And this is the another condition. So this is the bullshit condition that I was talking about, that this is just the start. So this means that currently the subsequence is empty. So simply go to the next index, and increment by 1, because obviously you have to take this element, right? Since it is empty, you are taking this element. There's no other chance. And then this is when the condition is not satisfied. So basically this is the else case of my uh, solution. This was the solution. This is the else case of my solution, when the this condition is not satisfied. So we cannot take this element. So I go to the next index, keep the j as same. And what is j? J is the last index of the last element in the subsequence, and do not increment the answer, right? And if all the conditions are optimal, then I can take the max of these two. First one is what? Sorry, here I left something. It was max of these two, since we have to find the maximum size of the subsequence, right? So yeah, so simply return max of either taking it. If I take it, uh, the last element in the subsequence will now be at ith index, right? And if I do not take it, it will be at the jth index still. And if I take it, the size will get +1. And if I do not take it, the size will remain the same. And obviously I go to the next index I +1. So this is more or less the DP solution that I have made for this C problem. If you have any doubt in the solution, you can again write it in the chat. Okay, so no one is seeing right now. Okay, so yeah, um, let's discuss the next question. Yeah, this the next question is a minimum same difference, right? Okay, so this question is a pretty hard problem, I would say, uh, from the PNC topic, and obviously, you must have a strong hold in permutations and combinations if you want to solve this question. Okay, so first of all, let us read the question. It says that for an array A of which has a size of n, we define f of A as follows. If A contains n distinct elements, then f of A will be equals to 0, right? Okay, so if there are n distinct elements, for example, what is an example? If the array is, let us say, 1, 2, 3, and 4, then the answer, then f of A will be 0. But otherwise, for example, it is 1, 2, 4, 2, then it will be minimum of j comma I among all the pairs I comma j that satisfy ai is equals to aj, right? So for example, in this one, this pair satisfies ai equals to aj, and the distance between them is what? 2. Distance is 2, right? And the minimum distance, obviously there is only one, so the minimum also 2. Now you are basically given two integers n and k, and your task is to find the sum of f of a over all the arrays of size n which satisfy this condition. So basically, every element of the array is lying in this range 1 to k, and the size of the array is n. So since the answer may be Raj, you have to print it modulo this number. This is a large prime number. Okay. So um, as I told you, this is a pretty hard problem from the PNC topic. Um, okay, so let me explain this test case first of all. So, for example, this is a 2 comma 2 test case, right? So the size of the array should be n, and the numbers must lie in 1 to 2. So obviously there are four arrays possible: 1, 2, and 2, 1. So 1, 2, 2, 1. Let me write the arrays. Let me write the arrays: 1, 2, 1, 1, 1, 2, 1, and 2, 2. Right? These are the arrays that are possible. Now, in this, since there are n distinct elements, the answer is simply what? 0. In this also same, 0. But in this, what will be the answer? Minimum of j minus I among all the pairs where ai equals to aj. So for this pair, index equals to 1 and index equals to 2, the answer is 1, right? And similarly here, the answer is 1. So the total after adding the all of them will be 1 plus 1 equals to 2, and that is the answer over here, right? So now you will be given n and k in a good enough range of 2e5, so that you can not calculate all these array by your hand, like I did in this question. For example, in this, there will be 420 raised to the power 343 arrays, and obviously you cannot write such number of arrays. So obviously the only possibility that you can use here is the permutations and combinations, right? Okay, now let me start with the solution of this problem. Uh, and also side by side, let us open my solution as well. So yeah, just first of all, I've taken the input of n and k and handled the side edge case. So for n equals to 1, the answer will obviously be 0, as it is also evident in this case. Why is it 0? Because if n equals to 1, obviously all the numbers will have to be distinct, right? If n equals to 1 and k is anything, so basically let us say the array is 2. So obviously there is only one distinct number in the array, and the answer has to be 0 according to the first condition. If the array contains n distinct elements, the answer is going to be 0. So if the n equals to 1, simply I have returned 0 handling the edge case, and then I have then there is the main logic of this question. So Yeah, let us actually start with the main logic right now. Okay. Yeah. So, as we know that we have to calculate these things, right? We have to calculate the sum of f of a. We have to calculate the sum of f of a and of over all the arrays, over all arrays of size n with ai in range 1, so closed interval 1 to k. So by basic p and c, um, n slots and each slots has k options, so there will be k to the power n total arrays. Yeah, that should be really clear, I guess. Right. And now what I want is that, like, uh, like when the answer will be zero, when the answer will be zero, when all the distinct elements will be there in the array. Okay. So let us consider this case at the end. When will the answer be 1? When the elements will be at a gap of 1, right? When the elements will be at a gap of 1 only. Uh, so what I have to calculate is that if the gap is equals to 1, right? If the gap is equals to 1, then my answer will be 1. If the gap is equals to 2, and what is the gap here? Basically, the gap between the pair, like in the example 1, 2, 4, 2, the gap here is what? 2, right? The gap here is what? 2. In the example 1, 2, 3, 4, 4, 3. What is the gap? The gap can be uh, 3 or 1. And since in the question it is said minimum, so the gap has to be what? 1. Right? So here the gap will be 1 and the answer will be added as 1. So if gap equals to 2, like in this case, the answer that will be added is 2. And then gap equals to 3 into 3. And so on up to what can be the maximum gap? Maximum gap can be n minus 1, right? Maximum gap can be what? 1, 2, 3, 4, 1. So here is a gap of 1, 2, 3, and 4, and the array was of size 5. So maximum gap can be what? Gap can be n minus 1, and the answer for that case will be n minus 1, right? This is the this is my final sum that I have to calculate. Is that clear? That is what is asked in the question, and we are currently naively approaching this problem. Okay, so sum is equals to this, right? And then what is my option? So instead of calculating this directly, what we can do is just gap greater than equals to 1. So what will gap greater than equals to 1 include? All of them, right? All of them. So basically this will now be added only once. This will now added only once. This will be added only twice. This will be added only n minus 2 times. Is that okay? Is that okay? I think it is. And then we will add gap greater than or equals to 2. Now, this was occurring only one time. This has vanished. This was occurring two times. This is left one time. This was occurring n minus 2 times. This is left n minus 3 times. And again, gap greater than equals to 3 plus gap plus so on basically up to gap greater than or equals to n minus 1. Uh, Obviously, the last condition will be gap equals to n minus 1. So, this is the idea, first of all. And I hope you would have understood this. Um, If you have not, let us try to generate this one from this one, right? So how many times does gap equals to n minus 1 come in this? So n minus 1 is greater than equals to all of these. So it comes how many times? N minus 1 times. Is that clear? And then gap equals to 3. How many times does that come? So it will come 3 times. Is that clear? So basically, I have just represented in this format. Now, just we have to focus on calculating the ways for gap greater than d. Now, for gap greater than d, for gap greater than d, what will happen? Sorry, not greater than or equal to d, and we just have to sum this up from d equals to 1 to d equals to n minus 1, right? And then, okay, so how will we calculate gap greater than or equals to d? So if we want such a gap, do you agree that the first d minus 1 numbers have to be distinct? First d minus 1 numbers have to be distinct. Do you agree? Because why do they have to be distinct? Why do they have to be distinct? First d minus 1 numbers have to be distinct. Why do they have to be distinct? Because if they are not distinct, the gap will be less than d, obviously. Like, for example, I say uh, gap has to be greater than equal to 2, and I am saying that first two numbers are 1 1. So obviously the gap is less than 1, right? And if the first two numbers were distinct, 1 2, and the next was 1, yeah, the gap is equals to 2. Now this is good. So the first d minus 1 numbers have to be what? Have to be what? Distinct, right? And then next number has to be different from the previous d minus 1 numbers, right? Next numbers, for next numbers, what is the condition? They must be different from their previous d minus 1 numbers, right? So the the main thing that I am trying to focus right here is that, let us say I am a number 8. I am a number 8. Should I encounter any so basically the gap should be greater than equals to d. So should I encounter any 8 in the previous d minus 1 places? Should I encounter any 8 in the previous d minus 1 places? No. Otherwise, the gap will be less than d. That's the problem. So, the previous d minus 1 places have to be what? Not equals to 8, right? So, how many options are left at a position? How many options are left at a position? If I am having no constraint, the only constraint in the question is that AI is in range is in range 1 to k. But right now, if I am at a number among these, not the first d minus 1, among these, if I am at a number after the first d minus 1, I have one more constraint that I cannot be equals to the previous d minus 1 numbers. So how many options am I left with? K minus d minus 1. Is that correct? Is that correct? I hope it is correct. So yeah, so this is the ways. And how many times will this be multiplied? So this will be multiplied again and again, right? So for the all the numbers after the first d minus 1 numbers. So how many times will it be multiplied? N minus d minus 1. Since first d minus 1 numbers are independently distinct, they do not depend on their previous, right? So they are not restricted, but these numbers are restricted, and these are how many? N to the power, sorry. k minus d minus 1 to the power n minus d minus 1. Is that correct? This is the number of options we are left with, and this is the number of such places after the first d minus 1. And yeah, so this is clear. And what about the first d minus 1 numbers? What about the first d minus 1 numbers? The first d minus number is what? Simply what? Uh, you can select d minus 1 numbers from the k numbers that you can use, right? And you can arrange these d minus 1. Is that correct? Is that correct? Arrange these d minus 1 in according to d minus 1 factorial. I hope that is correct, right? I hope that is really correct. Okay. Um, Now, for the first d minus 1 number, this is my result, kc d minus 1 into d minus 1 factorial, since they are not restricted. And for the next ones, this is my result. For the next one, this is my result. So overall, for gap greater than equal to d, for gap greater than or equals to d, how many possibilities are there? Uh, so simply, if you are aware about permutations and combination, this thing is nothing but the k comma d minus 1 permutations of d minus 1 integers from k minus 1 from k, right? So p k d minus 1. So this is nothing but p k d minus 1 into what? Into this thing right here. This thing right here, right? Is that clear? Is that clear? This is my condition for gap greater than equal to d. So I will be adding this thing for all this, and this can obviously be computed in of and time, right? Of even in O of one time also, if we had you know pre-computed values. So yeah, uh, this is the ways for calculating gap greater than equal to d. And once we are done with this was the main part of the question. And then as I told you that this first condition we will be dealing with this in the last. So if a contains n distinct elements, f of a equals to d 0. So as if you think about it carefully, in the gap equals to one condition, okay, let us say I have the array this. Let us say I have the array 1, 2, 3, 4, right? Does it violate this condition? The next number must differ from their previous d minus 1 number. Every number differ from their previous d minus 1 numbers, right? I think that is very right. So whatever is the gap, these numbers with all the distinct elements will creep in all of these, right? In all of these. They are counted again and again, and how many times? N minus 1 times. So what will I simply do? I will simply do answer minus is equals to n minus 1 times n minus 1 times what? Pkn. Why pkn this time? Because now I have k integers for AI and n slots, right? So I have to arrange n in I have to arrange k integers in n places, right? So p k choose n, right? And when will this be valid? So basically, there can be a case when this is not even valid if k is less than n. If k is less than n, obviously there are numbers repeating. For example, let us say if k equals to 2 and n equals to 3, then you have numbers like 1, 2, 1, 1, 1, 2. You can never have n distinct numbers, right? So yeah, for this to hold, k should be greater than or equals to n. This has to be subtracted only when k is greater than or equals to n. Is that clear? I hope that is clear, and that is all of the P and C that I have to apply in this question. So implementing is not a difficult task. In this question, the main difficulty was the logic, and that has been carefully broken down by me right now. Right. So yeah. So this loop right here is just calculating this value. This value. I mean, uh, at uh, at the time of the contest in some hurry, I have not written it really clearly. So I think the implementation part is not that much important in this question. If you are able to figure out the logic, let me write it all at once, or maybe you can write it yourself. What is the final answer? Final answer is final answer is sum 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 of this from d equals to 1 to n minus 1 and minus minus when if k is greater to L. So this is basically an indication. If k is greater than equal to n, then this value will be 1, otherwise it will be false or 0, right? And if k is greater than equal to n, then I have to subtract this thing. This is the main, you know, crisp of this question, right? And this has been implemented in the following way. This loop is implementing this sum from d equals to 1 to n minus 1. And then this loop right here, this is just calculating this thing to subtract. And in the last, I'm subtracting this thing n minus 1 times, right? And if I mean, you do not really need this condition since it is a modulo already. And finally, you have to see out a, right? So this was my logic and this was my code for the question. I hope you enjoyed this tutorial and you learned something new from it.